How's it going, everyone? This is Miss Ortiz, and this is your module on combustion reactions. You should start a timer for 30 minutes right now to see how well you do. There are 12 total slides in this module and several Nearpod activities. Let's go ahead and get started. The driving question for today is, what do fuels do chemically when they burned? We're just talking about the things that burn at this point. Radioactivity and nuclear energy are going to be a different module. So go ahead and make sure you write this driving question in your notebook. You don't need to answer it yet, but by the end of this module, you should be able to have an answer. You don't need to recreate this graphic organizer in your notebook since you should already have a copy of it. But what I wanted to do is I wanted to talk about where we're going to zoom in today. We're going to be talking about the process by which chemical energy or potential energy is converted into kinetic energy. So in this specific one, we're going to be talking about the chemical energy from the bonds in chemical fuels like natural gas and coal into heat energy or thermal energy, which is the energy of those particles moving around. My face is disappearing here so you can see the entire side. But your first definition that you should go into your notebook is that of a chemical reaction. And put simply, a chemical reaction is something that happens when molecules rearrange their bonds by breaking some bonds or creating new ones. The process of chemical reactions involves electrons moving around and reshuffling with each other. And there are lots of different kinds of chemical reactions. Combustion reactions are just one type. So what's the general format of a chemical reaction? We're always going to have reactants on one side. Then we're going to have an arrow that tells us what direction the chemical reaction is going. And we're going to have our products on the other side. You should have a generalized formula for a chemical reaction in your notebook. Take some time to do that now. You should already have a couple of things on your notebook page. You should have the driving question, the definition of a chemical reaction, and the general format for a chemical reaction. Now we're going to look at the definition of a combustion reaction. So a combustion reaction is a type of chemical reaction. Generalized reactions are at the top of our umbrella. Combustion reactions are one of a few kinds. So a combustion reaction is a chemical reaction in which a substance, like a fuel, reacts with oxygen gas and releases water, light, and heat. Here's a general copy of a combustion reaction. We have some sort of fuel plus oxygen gas, and we have products of water, and this little delta symbol is the symbol for heat. Let's look at one of the reactions that is a combustion reaction that we use on a daily basis here in Tucson. So remember, natural gas is one of the things that we use to generate electricity here in Tucson. And that has the formula CH4, 1 carbon and 4 hydrogens as one molecule together. The kind of bonds that are taking place in this are going to be covalent bonds. Hydrogen and carbon are all sharing electrons with each other. So when we burn natural gas, it burns with this equation. 1 molecule of CH4 reacts with 2 molecules of oxygen and releases 1 molecule of carbon dioxide and 2 molecules of water, as well as light and heat. Make sure you write a copy of this reaction down. You're probably going to see it as a quiz question. There's lots of different kinds of coal, and even then, it's a pretty complex set of molecules, and there's many different kinds of molecules that are present in coal, but mostly it's carbons and hydrogens, just in a long chain, or a longer chain than natural gas. It's kind of hard to describe, so let's look at a picture of one of the kinds of molecules you might find in coal. Pretty complicated, right? So when we discuss coal, we just write it into our reaction equation, kind of like this. So what I want you to do is figure out what the products in this reaction are and see if you can tell me which ones. Carbon dioxide and carbon monoxide aren't the only products that we get from burning coal besides light, heat, and water. Depending on what kind of coal it is, there's lots of different stuff that might still be in the coal. So you might wind up burning little amounts of nitrogen and sulfur and get different gases that come off that. But since coal doesn't have one kind of definition, it's kind of hard to tell you very generally what gets released. I can tell you though that carbon dioxide and carbon monoxide are pretty common products of a reaction. So what you're looking at right now is a graph of the various different kinds of coal that exist, and this is from like a government website that I have copied and pasted here. You can see the different kinds of colors of coal that represent the different kinds of coal that exist. So the ones that I want to focus on really quick are going to be lignite, subbituminous, and bituminous coal. These are the kinds of coal that we use to generate electricity in the United States. These ones are called anthracites, meta-anthracite, anthracite, and semi-anthracite. These have much higher amounts of energy per kilogram, but because they're so high energy, we wind up using them for residential and commercial heating. So you might have a coal furnace in very cold places in the United States. Not maybe so much in Minnesota. We mostly had wood stoves and natural gas furnaces. This is a screenshot from a website that I have in your resource list. So if you're having trouble finding it and you want to use it for your own project, you're more than welcome to do that. If you can't find it, just let me know. But it has some energy amounts in megajoules per kilogram for natural gas, hard black coal, that's our anthracite coal, and then you see the subbituminous and lignite coals here. You can see that the hard black coal has 23.9 megajoules per kilogram, and the lignite coal generates about 17.4 megajoules per kilogram or less, depending on what it has. And then there's some definitions, so IEA versus Australia and Canada definitions. What I want you to notice is that the units in this picture are in megajoules per kilogram. And if you go back to the previous slide, you'll find that they're in BTUs per pound, British thermal units per pound. Be prepared for a quiz question where you'll have to convert from one to the other. That's a big fat hint. All right, have a look at your notebook. At this point, you should have definitions of a chemical reaction, a combustion reaction, and reaction equations for both natural gas and coal. The last thing you should do before you call it a day is try and answer the driving question. What do fuels do chemically when they burn? Summarize your answer in your notebook and be ready to type up what you answered in a Nearpod question. I'm about to tell you my answer to the driving question, so now is a good time to check your answer against mine and see how accurate you are. Go backwards in the video if you need to compare your answer against mine. And after this, you can close the Nearpod and check in for credit. So my answer to the driving question is that a fuel reacts with oxygen in a combustion equation. And that reaction generates heat, light, and water. Carbon dioxide and carbon monoxide are byproducts of this reaction. And sometimes, depending on what you're burning, other things might be involved as well. Compare your answer against mine and see how well you did. And then once you're done, you can close out this Nearpod, and I hope you have a wonderful rest of your afternoon.